All right. Hello, everyone. How's everybody doing today? Excellent. I'm well. Sleepy though. Had to take the pupper to the vet for an early appointment, and I'm not a morning person, so I'm sleepy. Um, but I guess she's fine. Had to go for some blood tests. Um, because well, we tried earlier at a previous appointment, but apparently she was too wiggly. So they gave us some medication, um, which made her not wiggly. Um, yes. Well, I don't know. You ever see a dog that's stoned? Um, so I've been kind of keeping an eye on her all morning so she doesn't fall down the stairs or anything crazy. Um, but yeah, she's fine. Good pupper. We're just making sure that she's good. See, she's a senior. She's oh, how old is she? Well, it says here, doesn't it? I think she's 14. Yeah, 14. So we just want to make all of our critters, my partner and I, all of our critters are getting older. So we just want to make sure they all have very nice, relaxing retirements. Um, but on to today's topic. So, we're talking about causal theoretical functionalism. That is, we're going to look at the mind as a causal system. So, last time, I know we didn't follow Kim too closely, but I think we did hit all the main points, right? We talked about the mind as a Turing machine. And a Turing machine is like an imaginary mathematical machine, which Alan Turing conceived of in order to formalize the notion of computation. And he formalized it as algorithmic or rule governed information processing. And he illustrates this with the Turing machine, which is, again, an imaginary machine which has a tape. There are cells on the tape. Um, there can be symbols on the cells. These symbols represent information. Say, like computers represent information. Perhaps a zero represents false and a one represents true. So the symbols on the tape do something like the transistors on microchips, right? The circuits are on or off. Um, if they're off, zero, false. If they're on, one, true. Uh, it has a machine head, so it can move the tape around, delete symbols, write new ones, and it has a machine table, which contains all of the possible states that our machine can be in. You can think of this kind of like a computer program. So Turing uses this to do a number of things other than formalizing the notion of computation. He also shows that anything that can be solved algorithmically, any problem that can be solved algorithmically, can be solved by a Turing machine. And he further proved that there exists a special kind of Turing machine, which he called a universal Turing machine, that can implement or run any specialized Turing machine. Then, of course, we talked about the Chinese room and the Turing test, or I suppose the Turing test and the Chinese room. This was all sort of by way of getting us to understand what functionalism is all about, because after all, Hillary Putnam came along and likened the human mind to a probabilistic Turing machine. The brain is like the physical realization of a Turing machine. Now, Turing didn't build a Turing machine. He did build computers, but the Turing machine he describes in On Computable Numbers is, again, an imaginary, or if you like, an abstract mathematical kind of machine. But we could make one. We could make one with a tape, with a machine head, and that works mechanically. We could make a virtual Turing machine out of software. Um, that would be the physical realization of the Turing machine. And if Putnam is right, our brains are the physical realizers of Turing machines. And our mental states, well, these are like the logical states of the Turing machine, or the formal or functional states. Um, this is the abstract side of things. So like the actual symbols on a tape. Oh, well, maybe they're not symbols on a tape, but a symbol on a tape is a physical pattern. A series of symbols might represent some bit of information. Um, the information that it represents, that's the abstract part. And so our mental states are like that. Our brains are the physical realization of the machine, but our minds are like the logical side or the formal side of all of this. So, and on functionalism, it's important to remember that the physical realization is not what is really important. What's really important are our mental states and their functional relations. So, what do I mean by the functional relations? Well, think of pain, right? I have maybe some tissue damage, C fiber stimulation, a sensation of pain, and then I output some pain behavior. So the mental states, the idea is the mental states are mediating these input-output relations. So um, sensory, perceptual inputs, computation in the middle, and then behavioral outputs, or potentially outputs, other sorts of mental outputs too. Um, if I burn my hand, I've done this before, in fact, like on a hot pan handle, right? If I'm cooking with a new pan, and the handle is not well insulated, I might grab it without protecting my hand, and I burn myself, and I go, ouch, right? So I have some tissue damage, C fiber stimulation, pain behavior. Um, uh, but I have mental outputs too. Like I have a sensation of pain, and maybe I form the desire not to have done that. Or I form the intention, like, okay, remember next time, use your oven mitt when you're grabbing that handle, right? Um, so we'll get into more of that later, both in terms of pain qualia and qualia in general, and mental outputs as opposed to just behavioral outputs. But that's something important I wanted to reiterate. Also, I guess just to like reiterate this final point, uh, all of this can be implemented or realized with different stuff, right? And again, you want to think back to the calculator example here, or the heart example that we looked at on Monday. A calculator can be realized with, like a little circuit board kind of thing with some buttons on it, like a pocket calculator. It could be a software calculator like you have on your phone or your computer, where your calculator is basically like an app. Um, you could have an abacus or a slide rule, you know, it's the different ways of implementing a calculator. What makes it a calculator is that it calculates. What makes something a heart is that it pumps blood. So I could have a four-chambered heart about this size, the size that I could hold in my hand, and that's a heart because it pumps blood, not because it's what it's made of or how many chambers it has. Fish hearts have like two or three chambers, depending on the species of fish. They pump blood to and from gills rather than lungs, but that doesn't matter. What matters is how it's functioning. I could be fitted with some kind of artificial cyborg heart, um, and that would still count as a heart. It would be an artificial heart, sure, not a biological heart, but it would be a heart in virtue of its function. That is, pumping around blood, taking my deoxygenated blood from my organs and moving it to the lungs, and taking the oxygenated blood from the lungs and moving it back around to all my organs. What about the heart of a city? Well, that's like a figurative heart, right? Um, in that, the heart of a city might be, well, what might a heart of the city be? What's the heart of Ottawa? Is it the Parliament buildings? Is it the Byward Market? Um, Maybe it's the Rito Center. Yeah. So that's like a figurative in the sense. But maybe it might make sense. Like if you say, "Oh, the Rideau Center is the heart of Ottawa," as opposed to the brain. It, you're analogizing it with the heart because people come and go from from the Rideau Center. Um, Maybe the brain is actually, I don't know, City Hall, right? Um, so that's figurative, right? Um, and maybe there's some interesting reason why we accept certain figurative descriptions as good ones, because there are certain kind of similarities like that. But for our purposes, we're mostly interested in the functionalist stuff. So, important thing to note. Yeah, okay. So, important thing to note. Um, is this input output sort of picture, right? Sometimes we call this the sense, think, act cycle, um, which I guess I can try to annotate. Oh, I can type. Cool. Okay, so you can think of it like this. I can type this out here. This is how it's discussed in well, computer science, robotics, sense, think, act. So um, whether you're talking about like a Roomba vacuum or a human being, well, actually not a Roomba because that's a different sort of cognitive architecture. Say a Mars rover, right? Whether you're talking about a human being or a Mars rover, on functionalist descriptions of mind, you can think of what they do as kind of like this. You have sense organs. So if I'm a Mars rover, I have sensors, cameras, and so forth. I have a CPU. And some computer software so I can think and then I can act. Do I go over here or over there? Do I take a sample here or over there, right? So sense, think, act. Same with a human. Like sense, my I got some tissue damage. Ouch, that hurts. Act, pull my hand away from the thing that's burning me. Sometimes we also call this the um, classical sandwich. So there it is on the screen, just so that you can, I guess, make note of these interesting terms. So we have the sense, think, act cycle, or the classical sandwich, where you have sensation and action, or perception and action. They're like the bread, and the thinking is the meat and the veggies in the middle of the sandwich. So that's one way you can think of this input-output relation here, which is what I really want to draw your attention to. That's our input-output relation. What does causal theoretical functionalism do with this input-output relation? Well, machine functionalism looks at all of this in terms of a Turing machine. Uh, Causal theoretical functionalism understands all of this in terms of causal relations. Here's what Kim says. Kim says causal theoretical functionalism conceives of this input-output relationship as a causal relation, one that is mediated by mental states. Different mental states are different because they are implicated in different input-output causal relationships. Pain, for example, differs from itch in that each has its own distinctive causal role. Pains are typically caused by tissue damage and cause winces, groans, and escape behavior. In contrast, itches are typically caused by skin irritation and cause scratching. Um, so that's the important difference. And one thing that we're going to get to later is the role that qualia has in all of this. So you might think, okay, what is on pain? What is, or on functionalism, what is pain? Well, think in terms of this, the classical sandwich or the sense, think, act cycle. Sensation is one of tissue damage. Um, think. It might not be that thinky, that cognitive. In fact, when we withdraw our limbs from painful stimuli, usually that's actually reflexive. And the withdrawal takes place before we actually feel the pain, right? But so I've withdrawn my hand. I might still think, oh, geez, I forgot my oven mitt. Got to remember my oven mitt next time. Um, so You see the idea, right? All of this is causal, where pain is the input, um, and withdrawal behavior is the output. Yes, pain hurts. We will get to that. And maybe my behavior can be mediated by mental states like my sensation of pain, or other beliefs and desires, right? When it comes to itch, the input is skin irritation, typically, and the output is scratching. Note that that can also be mediated by other mental states. Perhaps I've got some mosquito bites. I'm still up in North Bay, and we're right in the middle of black fly season up in northern Ontario, and the mosquitoes are starting to appear. So everybody's getting bug bites. And the thing about bug bites is they itch. But if you scratch too much, you're going to get a nasty rash. You're going to break the skin and it's going to maybe even get an infection, right? Gross. So, I might be thinking, oh, that's itchy, but I might think, wait, don't scratch that itch too much. You'll get a rash, right? How about instead we put some afterbite or something on it, right? You see the idea. Okay, let's get rid of these annotations here. So that's the idea. Now, there's a small worry is raised here, a worry of circularity. Kim describes the worry thusly. He says, to explain what a given mental state is, we need to refer to other mental states. And explaining these can only be expected to require reference to further mental states, and so on. A process that can go on in an unending regress or loop back in a circle. Moreover, quote, circularity threatens to arise at a more general level as well, in the functionalist conception of mentality itself. To be a mental state is to be an internal state serving as a causal intermediary between sensory inputs, mental states as causes on the one hand, and behaviors and other mental states as effects on the other. Viewed as a definition of what it is to be a mental state, this is obviously circular. So we need to escape this worry. And machine functionalism does it with the Turing machine. So mental states are defined in reference to other mental states. For example, can you come up with an example? I'll try and think of one too. I don't think Kim actually gives us one, um, but maybe we can come up with one. I believe I love cheese. Okay, so you have a belief you love cheese. So how do we understand what it is to love cheese? Um, I guess we'd have to understand your belief that you love cheese in the context of other beliefs, like your belief that cheese is fermented, like fermented milk curd. hmm And then that would be defined in terms of other beliefs, like beliefs about what fermentation is, and so on and so on. Um, if I may, I think this might be Kim giving us a little bit of a dig against something called coherentism. So coherence theory or coherentism is like an epistemological theory that's due to Quine. Um, so if you want to think back to Descartes, Descartes is what we call a foundationalist. So a Cartesian sort of epistemology has certain um, irrefutable, indubitable, foundational beliefs upon which other beliefs are built up. For Descartes, that was the cogito, right? I think, therefore I am. That was a belief that Descartes thought that was impossible to doubt. Um, he builds all of his other knowledge up on top of that. Um, Coherence theory says that everything uh, there's not really like a foundation to our beliefs in that way, but rather everything sort of hangs together like a spider web. And then what's important is that beliefs which are a kind of mental state, all cohere with one another. And one criticism of coherence theory is that a system of beliefs can cohere perfectly well, but they need to be, there's no connection to the world. Um, so how do we how do we sort of it's not just a question of defining um, the roles of mental states or um, uh, to explaining what mental states are, right? This is more of an epistemological problem than a problem with philosophy of mind, but it's related, I think, to coherentism, which I don't quote me on this, but Kim may not have been a fan of this. Because Kim is also well known for some of his replies to other of Quine's ideas, like his ideas of natural epistemology. We don't need to get into all of this. I just think maybe this is like an objection against a sort of coherence theoretic version of philosophy of mind. It's an epistemological theory, um, but a similar sort of problem is happening here. Machine functionalism uses the Turing machine to escape the circle. Okay, so the mental states are, uh, defined in terms of their functional roles, but they're implemented via the physical states of the Turing machine. So what it is to be in a state of pain um, is to have tissue damage, and then the output is pain behavior. And what you're doing when you're doing all of that is that you're actually realizing a sort of Turing machine description of pain, right? What causal theoretical functionalism does is it exploits the causal relations involving all mental states to try and escape the circle. So this is when we get to the tough part, the Ramsey-Lewis method. Now, I feel I should put the question to you. What did you make of this part of the chapter? This is the technical part of the chapter. Did you find it a little bit intimidating? It's okay if you did, because that's why I'm here after all. But I want to make sure we go through this slowly, because it is, pretty technical. You can be honest with me. Who kind of skipped this part? Timothy. Okay. Yeah. Well, we won't be skipping it here, but I will be explaining it to you. And then I hope that you do go back and look at it in light of what I say today. To try and illustrate what causal theoretical functionalism is all about, Kim formulates a toy theory of pain. So, not a complete theory of pain. We don't have that. But like a little simple theory that can serve as an example for illustrative purposes. So, here's our theory of pain, which we call T. So, on T, for any X, for any being, if X suffers tissue damage and is normally alert, X is in pain. So if I'm normally alert, like I'm up in the morning, well, not the morning because I'm not a morning person, but if I'm up and making delicious breakfast, I'm normally alert, but I suffer tissue damage, say by burning my hand or maybe cutting myself with a knife, then I will experience pain. Further, if I'm awake, I tend to be normally alert. So I'm awake, I'm normally alert, sure. If I'm in pain, I wince and groan and I go into a state of distress. Okay, so I'm alert, I've suffered tissue damage, I'm awake and alert, I'm in pain, I make winces and groans, I suffer distress. If I were not normally alert, though, uh, or if I am in a state of distress, I might make more typing errors. So after I've injured myself and I'm prepping my lecture slides, I find I'm making more typing errors because I'm in pain. So it's a toy theory that spells out a bunch of stuff about mental states like pain, um, as causal intermediaries between inputs like tissue damage, and outputs like pain behavior or typing behavior. That's all that's going on here. Okay. Now, uh, since this is a theory, what we want it to do is describe causal relations. That is laws or law-like relations, or causal nomological relations, as Kim refers to them in this chapter. So to make this clearer, just note the following. Note that everything in italics describes non-mental predicates, properties that we can predicate. Um, these are here physical, biological, or behavioral properties. So if X suffers tissue damage, that's a physical property. Having tissue damage is a physical property. Being awake is a psychological property. Making typing errors is a behavioral property. So everything in italics is a a non-mental predicate. So forget about the mental stuff. The bold font are the psychological predicates. So here we have a biological or physical predicate, um, and what's in bold is a psychological predicate. So X, say I'm X. If I have tissue damage, I have the property of having damaged tissue, and if I'm normally alert, then I have the psychological property of being normally alert. And if these two conditions obtain, then I am in pain. Okay? Make sense? Just keep in mind, it's not a complete theory of pain. It's not meant to be exhaustive. We're just using this to illustrate the Ramsey-Lewis method, which is named after Frank Ramsey and David Lewis, a couple of logicians. Now, I want to make sure we're all good here. You might be thinking, like, what are we talking about? Making typing errors or being alert or not normally alert? What does this all mean? All this means is that, okay, so we've got something, an X, your X, and if you suffer tissue damage, if we predicate, this physical biological property to X, so X is damaged tissue, but X is also normally alert, then X is in pain. Additionally, if you're awake, you tend to be normally alert. If X is in pain, you wince and groan and go into a state of distress. Further, if you're not normally alert, so maybe I'm awake but I'm not normally alert, like I'm still sleepy, or I'm in distress because I've burned my hand making breakfast, then the behavioral predicate applies. I tend to make more typing errors, right? You see how it works? I'd really like to hear and I know you guys are great about contributing to discussion, but I'd really like you to tell me, don't be shy about telling me if this is still like, sounding like it's all Greek to you or something, because it's going to get a little more complicated than this. And I just want to make sure we're all following along. And my job here is to explain and elucidate all of this. So don't be shy. All right. I guess no one has any
It,
concerns.
it,
Oh,
it
oh,
is it like symbolic logic, I think,
we're getting to symbolic logic.
right?
Yeah, we're getting there.
I've learned a bit about that before and think, yeah,
Yeah, we're getting into a little bit of predicate logic here.
right.
And that's what we do when we ramsify our theory T. What we are going to do is existentially generalize over all of the psychological predicates that occurs in T. So remember, the psychological predicates are what are bolded. So normally alert, in pain, in distress, not normally alert. Those are our psychological predicates. Those are psychological properties that we can predicate to X. So we ramsify T and we get TR, or T after it's been ramsified. So we generalize. We say there exist states M1, M2, and M3, such that for any X, if X suffers tissue damage and is in M1, X is in M2. If X is awake, X tends to be in M1. If X is in M2, X winces and groans and goes into M3. And if X is either not in M1 or is in M3, X tends to make more typing errors. So In what sense have we existentially generalized over everything? Well, we've just said, okay, here, let's replace our specific mental states with M1, M2, and 3. These are what we call predicate variables. Okay? They're like the variables in, think of something like a mathematical formula. But instead of variables like X or Y, which we can put in whatever numbers we want. Here, we could add whatever psychological predicates we want. And that's the sense in which this is existentially generalized. Instead of referring to specific mental states, we now have M1, M2, and 3, which could refer to whatever sort of mental states we want them to. But here, they refer to the following. M1 is being in the normally alert state. M2 is being in pain. M3 in a state of distress. So in T, we have predicate constants. If I go back, for example. So is normally alert, is in pain, is in distress, is not normally alert. These are predicate constants. M1, M2, and 3 are predicate variables. They're topic neutral. Um, so where, like I say in this point here, actually, oh, let's go get back to my little stylus. T referred to specific mental states, but the Ramsified version of T refers to, as Kim says, some state or another. So think, for example, of, I don't know, a mathematical formula. Give me a simple mathematical formula. Oh, I knew it. I knew it. Y equals mx plus b. Oh, I still remember y equals mx plus b. So these are our variables, right? And oh, it's been forever. What is this for again? It's for finding the. It's for putting the line of best fit over your data, or it's to no, it's to find the y-intercept. Yeah, which the y-intercept of your line, so your y, we want to find y so we can plug in mx and b, and these could be, whatever numbers we've got, right? So tr is kind of like this for psychological predicates. So m is the okay, thanks Grant. M is the slope, x is a variable, b is the intercept, y depends on x. Okay. So we take our y-intercept and plug that into b. Then we take our slope. I guess so. We multiply the slope by whatever variable, and you do the math, and you get some number that equals y, right? But the point is that these are variables, and we could make them constants by plugging in, what our slope is, what our intercept is, etc. And then we can answer what is y, right? That is what the Ramsey-Lewis method is doing with our psychological theory of pain, T. We're taking it and we're making it general. We're making it like algorithmic almost, in the sense that, now I've got this one cookie cutter sort of formula that I can use no matter what specific um, uh, values I have for these variables. Depending on the problem, these are all going to be different numbers. But now I have a formula. So no matter what my numbers are, I have what I need to solve the problem. This is kind of like that. Okay, so far so good. Okay. Now Ramsey did show that TR is weaker than T. Because I can't remember the reason. TR is weaker than T, um, because T implies TR, but TR does not imply T, if I've got that right. But it's quite powerful in terms of physical behavioral prediction, just like T is. So we existentially generalize T as TR. The two theories, Kim says, make exactly the same deductive connections between non psychological statements. And now what we can do is define psychological expressions without worrying about any sort of circularity because we're not defining them with reference to other mental states. So now we're going to get even more logical and we're going to abbreviate TR. We abbreviate it thusly. This part that I've underlined here. So you might have looked at this and gone, what? Um, don't worry about it. This symbol here, this backwards letter E looking symbol, that's what we call the existential quantifier. It's just a logical shorthand for there exists. So now we have our pain theory. There exists M1, M2, M3. And our theory, our specific theory, deals with these three mental states. See how in this argument we're saying here there exists these mental states, and then this part in this argument here, we've got our theory with these three mental states. And then we can define pain. We can say that X is in pain. So X is in pain when, and remember this is the definitions part, when there exists mental states M1, M2, M3, and X is in M2. So M2, remember, is our predicate variable which replaces the predicate constant is in pain. So any X is in pain when we have these three mental states, and within our theory, out of those three, X is in M2. How are we doing? Grant's good, but what about I want somebody who's not as good to Shannon? Oh, that's Shannon who says good. Okay. Who's not good? Uh because I really don't want to rush through this. Like I said, I get it. I am not a math guy. I'm not even that much of a logic guy. I'm really an ordinary language guy. So I'll tell you in ordinary language. Again, our X, our person, is in pain when we have these three mental states and you're in the second one. Because we've decided M1 means normally alert. So this is really just saying X is in pain where we have these three mental states that exist, being normally alert, being in pain, and being in distress. And out of these three mental states, our theory says that X is in M2. So X is in M2 means that our X is in pain. We can do the same for all of the other predicate variables. We'll see on the next slide. Maybe this will make it clearer just in case. So we can define being normally alert. We still have the same three mental states, M1, M2, and M3. And X is in M1. Remember, M1 is normally alert, M2 is in pain, M3 is in distress. X is in distress if there exist M1, M2, and 3, and at some particular time on our theory, X is in M3. This is just a way of saying what it is to be in pain or to be normally alert or in distress using the predicate calculus, where we have predicate variables to which we can assign whatever property we want. These could mean different things. We could say that um, X is hungry if there exists mental states 1, 2, and 3, like um, um, grumpy, hungry, and satisfied, and X is in M2. That would be a way of saying X is hungry. Then maybe X eats something. Now we've got mental states M1, M2, and 3, which mean hangry, um, hungry, satisfied. I don't know. And X is in M3. So now X is no longer hungry. Now X is satisfied their hunger. So this might give you a headache, right? Which is to say that you're an X and you're currently in M2. Little philosophy joke for you. Um, but what does all this say in plain language? I'm sure that's what you want to know. Well, it says, according to Kim, that you are in pain just in case there are certain states, M1, M2, and M3, that are related among themselves and with such physical behavioral states as tissue damage, wincing and groaning, and typing performance as specified in TR, and you are in M2. So we have now a theory of pain where mental states feature as causes and effects along with our physical and behavioral states like tissue damage or making typing errors, respectively. Now, these concepts are all interdefined, but there really isn't any worry of circularity here. There's a question here. Maybe, Grant. Well, you might be able to because it's a toy theory, right? But remember, being interdefined is not the same as circularity. I mean, the circularity worry reminds me of there's a scene from Star Trek: The Next Generation. Okay, um, I think it's like the last episode of season 6, Descent, Part 1, where the Enterprise crew encounters a bunch of Borg, and something weird happens to Data. He's defending his shipmates from the Borg, these evil cybernetic organisms, right? Cyborgs, right? Anyway, Data gets angry, but Data's not supposed to get angry. Data's an android, and he doesn't have emotions. So uh, he's like, "What the heck? What the heck happened to me?" He's killed this Borg, and he's become angry because they were trying to hurt his friends. So later, he's talking to Geordi, the chief engineer, with the visor, um, and he's asking Geordi to describe um, uh, anger because Data's trying to make sense of what he's experienced, and Geordi can only describe anger by referring to other emotions. And Data finds this unsatisfactory. Data's like, can you define anger without referring to other emotions? Because Data hasn't experienced other emotions. Um, and Geordi kind of gives up and says, I don't know, you just kind of get angry. And Data says, yes, that is what I experienced. I just got angry, right? And that's the circularity worry, as illustrated by the crew of the Enterprise D from Star Trek. Make sense? So that's kind of the worry. But here, what we've done is we've interdefined the concepts. So these various. Whoops, my chat just got huge there. So all of these, right? X is in pain just in case that there exist these mental states and you're in M2. X is normally alert if we've got all these mental states and you're in M1. X is in distress if we have these three and you're in M3. It's not just these three individual definitions, but all the definitions together are how we have interdefined these mental states. So there's no circularity, but there is a sort of interdefinitionality, if that is a word. Something interesting to think about here, we can actually think of the Turing machine approach as a sort of special case of the Ramsey-Lewis method. Here, our psychological theory is presented in the form of a Turing machine table with the internal machine states, the Qs, responding to the predicate variables, the M's. What do you think? Yeah, toy means incomplete. For example, right? Like if I wanted to explain um, how a boat works to a child, I might use a toy boat. It's not a real boat. It can't really sail the oceans. Um, but I could put it in a pool and use it to teach the kid about things like buoyancy, for example, right? I could say that this real boats, big giant boats on the ocean that are really heavy, float for the same reason that this toy boat floats. So that's not a complete boat. It's too small. It can't carry cargo. It doesn't have an engine. It's just a toy. But it 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 might be helpful for illustrating buoyancy to a curious child. Um, that's what it means to say that we're dealing with a toy theory. So T and its ramification TR are toy theories of pain. Because after all, we don't have a complete theory of pain. And here's something interesting, where yeah, that's good, Grant. um, although that is, I would point out that this does appear to be a real boat, but you know, yeah. I'm thinking a toy example. We're like Paddle to the Sea, right? You ever see that movie? Um, it's like a little guy in a little boat, and he just floats down through the Great Lakes into the ocean, and we follow this little doll on a boat. That's us right now. Okay, so the point of this is that where the Ramsey Lewis method, I should say, the Ramsey Lewis method uses the predicate logic. What a Turing machine functionalist would say is like, well, we're really doing the same thing here, but instead of doing it in predicate logic, we're doing it with the machine table of a Turing machine. Um, Same thing. What do you make of it? What do you think? I see that we're down again to only 17 people. I think maybe some people have checked out from discussion of the Ramsey Lewis method. Grant, yeah, Grant's got it. Good. I mean, I guess even though I'm not naturally inclined to this sort of thing, I've just been teaching this class so long that I've got it. But like I said, I do appreciate if you are really coming from more of an ordinary language background, or I mean, if you have no background in logic at all, um, how this might be throw this could throw you through a loop. Grant says, I can see the relationship between turning something mental physical into a formula which can be calculated. Yeah. It's also a bit like computer programming. You know, when you're programming, if you ever done like object oriented programming, anyone ever done any object oriented program like with Python, for example? Yeah, so like when Python, you create objects and you give them properties. That's like what's going on here. So this is like a program. Our theory of pain, the Ramsified theory of pain, could be written out in like Python, and you could have like a little pain program. Um, same kind of thing. If you're really racking your brains though, send me an email. Timothy, go ahead.
So is it like we can just describe what it does rather than having to like know for certain what it
Well,
is, I
I,
guess.
I would I would like you to know for certain.
Okay.
Um, I mean, really, like it's the same thing. If you can describe what's happening here and here, then I think you've got it. Like what this is saying is that okay, so we've got some entity X which is in
Yeah.
pain when
That's
we've got these three mental states,
hmm
and X is in M2.
So given those three mental states, X and X being in M2, then X would be in pain.
Yeah. But if X is in M3, then it's in distress. If X is in M1, X is normally
Yeah.
alert.
Hmm.
It's really that simple. Like it looks
Looks
complicated.
complicated, but I guess
It's
it's
not
not
that
that.
complicated.
Yeah.
Like again, in plain language, what Kim says, this just says, quote, that you are in pain just in case there are certain states, M1, M2, and M3, that are related among themselves with such and such
If you
physical
have one of those
behavioral
states, then you're
states.
in pain.
Yeah.
Like,
So
basically, yeah.
like they're related amongst themselves and with other states like tissue damage, wincing and groaning, typing performance as we specified in TR, and you're in the second state. Um, yes, no, you're not missing out, Grant. That's the problem with functionalism. That is the that is the problem. Then we're going to get to it. Yeah. No, but it's exactly right. Like, okay, pain, I have a mental state which is caused by. Remember, this is all spelling out these. the role of these mental states as causal intermediaries between tissue damage and winces and groans, right? So these are not these are just that part. Remember, sense, think, act. These are the ingredients in the classical sandwich between the bread or between the bun, if you will, right? Um, but, and we will get to this, one thing that functionalism doesn't really do uh, is account for qualia, and that's what we're going to spend the second half of our lecture on. But good eye, Grant. And yeah, Terrence, yeah, like you said, or Timothy, I forget. Sorry, who was it that I was just talking to?
Yeah, Timothy. All good.
Timothy. Like you said, Timothy, um, it looks more complicated than it is, right? Um, but it's just a matter of like this is the sort of thing that you really do like learn by rote. So just keep in mind, like these are just like predicate logic sorted descriptions of like, oh, there's so many mental states that can serve as causal intermediaries between physical inputs and behavioral outputs. And what it is to be in pain is to be in the second of those mental states.
I guess it takes a while to click. Sometimes like
Yeah, like that's why I say repetition, like read over it. If you want, there might even be other explanations uh that you can find besides mine because again like I kind of I tend to explain this stuff in a way that makes sense to me, but the way that it makes sense to me might not make sense to you.
I,
um
I find that with philosophy courses, often like I kind of get the concept, but I don't think I get it because I can't really
yeah,
describe it well or
well, I
anything.
think that's what's happening here, and that's good. I mean, hey, you've got
Well,
the
that's part of learning. It's okay.
yeah, that's part of learning, and it's the Socratic virtue, right? You know that you know not, and that's a good thing, right? So
Yeah.
Um, so I'd say for anybody who's a little intimidated by this stuff, which I have been in the past, you just kind of stick with it, and eventually you get it, you know. Um, so one thing we've got to do is try to explain not just pain, right? We want to explain all psychological states. We want our theory to be expansive enough so that it encapsulates enough information about each different psychological state, not just the states themselves, but their inputs and their outputs. So those inputs could be physical, biological states. They could also be mental states. The outputs could be behavioral, but also other mental states. And we want our theory to be big enough that we can explain all of mentality this way. So, what options have we before us? Well, one is called common sense psychology, or as it's also known, folk psychology, or propositional attitude psychology. Think back to the desire belief action principle that we learned about, right? Which said something roughly as follows: if S desires A and believes that doing B is a reliable way to secure A, then S will do B, right? Um, this is how we make sense of the things that other people do in everyday life. That's why it's called common sense or folk psychology. It's kind of like an everyday psychology, propositional attitude psychology, because it relies on explaining the behavior of others by, in terms of um, uh, attributing propositional attitudes like beliefs and desires to them. So I'll give you some examples so that we can sort of flesh all of this out. I'll describe a situation to you. It's rather like one we've gone through before. So it is sunny outside, and you and your roommate are at home. You hear your roommate listening to the radio, and sometime later she leaves and takes her umbrella with her. even though it's sunny out. How would you explain your roommate's behavior? Or how could you potentially explain your roommate's behavior? She read the Weather Network. She did certainly. Maybe that's what she. Maybe the radio is a bad example. Probably she's looking at her phone. Um, yes, storm. She believes it might rain soon. What else? Well, I imagine she does like umbrellas, but additionally, she wants to stay dry when it rains. So she desires not to get rained on. Or, yeah, maybe it's not an umbrella at all. It's a parasol. And she wants to keep the sun off and not get a sunburn. That could work as well. Notice for either of these, you have to kind of infer other mental states. So you'd infer that she believes what she heard on the radio or on the Weather Network app. Um, she believes it's going to rain, or she believes that there's going to be a high UV index, and that she desires not to get rained on or not to get a sunburn. And she believes further that bringing an umbrella or a parasol is a reliable way to avoid getting rained on or receiving a sunburn, respectively, right? Another one that's kind of based on the the sort of thing that Searle was dealing with in his discussion of Shank's computer programs from the late 70s. Situation like this. Maybe you're dining out, right? And someone else at the restaurant comes in and orders a burger. Um, and you happen to notice sometime later that he's left without finishing his burger, and he hasn't left a tip. What could you infer, and how would you infer it?
If they're in a Western country, maybe they weren't happy with the service.
Yeah.
If they were in an Asian country, that's not really part of the culture, I guess.
Oh, like it's okay to leave unfinished. Oh, you mean the tipping? Or
Tipping, yeah. The
yeah,
tipping,
the
sorry.
tipping.
Tipping,
Yeah.
yeah.
Okay. Yeah. So, um, but I suppose even in those, even let's say I went to an Asian country. Um, if I took one bite of the burger and then left, you might still wonder, I guess he didn't really like that hamburger. Or maybe something
That's
else.
true. That's true.
Maybe I just had to go.
Yeah,
Like
yeah, yeah, could be.
oh, I forgot to pick my friend up from the airport. Ah,
Yeah.
so I just leave, right?
I
Um,
guess
but you're
something was more important than eating.
Yeah, so and you're right. I'm glad you bring that up because it does depend on because the different beliefs and desires we all have are shaped by the culture that we're in, right? So like you said, like yeah, if I'm at like a diner in Canada and someone takes one bite and goes and leaves and doesn't give a tip, then I guess they really didn't like the burger. But if I'm in a different country with different customs where tipping is not expected, then maybe I'd infer something else. Maybe it wasn't the burger. Maybe he didn't tip because he didn't like the service, or maybe he just didn't like the burger. If worrying about why he did not tip is not a concern, right? Um, Shannon says maybe he didn't get a good service. Yeah. Oh, yeah, yeah, exactly. Yeah, yeah. So good, good. You said that before I did. Shannon. So credit to you. Um, uh, like maybe the burger was fine, but the wait staff was rude, right? Um, so we could infer, or we can attribute mental states like different beliefs and desires to our diner customer. to try and work out why he behaved the way that he did. And when we do that, we're using folk psychology. Like Grant says, person wanted a good burger. He desired a good burger, but he believed the burger was gross. Um, Maybe he didn't leave a tip because the burger was too gross, and he thought, well, whoever cooked that burger is really bad at their job. No tip, right? Yeah, maybe they could be out for a cigarette and will be back for the rest of the burger. So maybe he desired a burger, but once he had a bite, he found that he had a stronger desire for a cigarette and believed that he could have a cigarette and come back and finish the burger, right? Um, See how no matter how we explain the situation, we are attributing um, beliefs and desires and other mental states to people. And we do this all the time, more or less unconsciously. Not all the time. Sometimes you're in a new environment, right? And you have to, you might see things that you don't understand, and you might have to think it through. Um, like for example, I've always wanted to go to Japan and go to Fukuoka, where they have those little food stalls on the street. Um, I like to watch videos of these cooks. They're really cool. They bring these food stalls. They're like on a little cart, and they set them all up, cook for a few hours, and then tear them all down and bring them home. Right, and it's a big hot spot. People are coming from after work to get supper, tourists. Just looks cool. Um, so maybe I go there one day, right? And I'd see like, boy, nobody's tipping here. Um, are they all dissatisfied with their service? Well, I might think that if I didn't know that tipping is not expected, right? So I might see something and have to think it through like, well, there's an awful lot of people not leaving tips, but they all look very happy. Maybe they don't maybe they just don't tip here, right? Um, so uh, yeah, it all like kind of depends. The background beliefs and desires that we have to bring um, uh, that we have to consider. We do it somewhat unconsciously, I think, but we might be in an unfamiliar setting and have to think about it consciously. There are also people that do have trouble with what we call theory of mind. I'm talking people on the autism spectrum, right? Um, for a long time, I think people had the impression that folks on the spectrum were like lacked theory of mind. Um, I don't think that's the case, and I don't think that research into the mentality of autistic individuals really supports this. It's more so that um, for somebody on the spectrum using uh, using common sense psychology is more like something you have to practice. Um, some people on the spectrum describe mind reading or theory of mind, or as we would call it using folk psychology, as like learning a second language. So if you're like in a new culture, or if you're on the spectrum, or anything like that, you might have to apply a little bit more brain power to your folk psychology. Uh, but I think most people do this more or less effortlessly and unconsciously. Although, who knows? People still misunderstand one another, get their feelings hurt, um, cause offense, etc. Right? So common sense, Grant says, mostly means common to the area. I guess common within, I would say common within your community or culture. Like what is common to you in your particular time and place. So all this is to say, if we go with folk psychology, then what we have opted for is analytical functionalism. Another option is scientific psychology. So the kind of psychology you learn in your psychology classes, right? What cognitive psychologists or cognitive scientists do. where they try to formulate precise theories that explain the causal relations between inputs and outputs. If we do this, we're going with what's called psychofunctionalism. Think of what um, psychologists do when they study people, right? They try to identify what we call effects. If we want to think back to the psychophysicists, they identified all kinds of effects, like uh, I forget the name of this particular effect. Actually, it's escaped me. Um, but there are effects. Oh, the Barnum effect. There's a good one. The Barnum effect. Who can tell me what the Barnum effect is? So the Barnum effect is named after P.T. Barnum, the one of the guys behind Barnum and Bailey circuses. Um, he was known for, other than a circus guy, he had like these houses of curiosities um, with a lot of nonsensical things in them, like mermaid skeletons, um, which were obviously cobbled together from the bones of humans and animals. Barnum is famous for the phrase, "There is a sucker born every minute." Um, but what he's less famous for is the phrase, "There's something for everyone." So if you went to the Barnum and Bailey Circus, or if you went to one of his little museums, there was something for everybody there. Something that someone, no matter who you are, would find interesting or curious or entertaining. And so the Barnum effect, it's like there's something for everyone. Barnum statements are vague, general statements that could apply to anyone that people think apply specifically to them. So the Barnum effect is when people think that Barnum statements apply specifically to them. For example, you're at maybe you're at one of Barnum's circuses, um, and there's all these interesting things you can do, like you can play that game where you hit the thing with the hammer, and you have to make the little, I don't know what it's called. I don't know the technical term, but you hit something with a hammer and a little thing goes up and you have to try and make it ring a bell, right? The guy might say to you, "You there, you look like a strong young man," which maybe could apply to anybody, any young man. But you think, "Oh yes, I am very strong. I'll give it a try," and spend all your money trying to hit this thing so that you whack it hard enough with the hammer so that the little thing goes up and hits the bell. Or those card shark guys that play three card Monty on the street. Like, you look like a lucky person, so you come and you play three card Monty and lose all your money, right? Or the biggest example of Barnum statements, horoscopes. You could probably go online and find a horoscope somewhere. Actually, if somebody wants to do this, go online, find a horoscope, and we'll see that it's full of Barnum statements. Does anyone want to take a look? I will. This is going to mess up my search history looking up horoscopes. Let's see. Horoscope for today. Ah. Oh, Grant's got one for Pisces. Stress might be getting the better of a household member today, Pisces. This person feels emotionally volatile. The least irritation could set off a temper tantrum. Try to ease the pressure by staying out of the way. Don't offer it. Yeah. So, I mean, this could apply to any number of people. Um, Here it's a little specific, a household member, but I don't know. Here, Elle magazine. Do they have some good? Oh, you have to hit specific ones. Oh, okay. Well, let's see Virgo. It won't be easy to interpret what's really going on with people or a certain person today. How apropos of our discussion of philosophy of mind. Chalk it up to a stressful square between trickster Mercury in your communal 11th house and confusing Neptune in your intense intimate 8th. Okay. Um, yeah, fortune cookies too. Yeah, they have Barnum statements. Yeah. Um, so like it won't be easier to interpret what's really going on with people today. I mean, welcome to every day of my life. Um, and I imagine many other people's lives. So yeah, Timothy, you had your hand up there.
Yeah, I found one that says oppressive stress on those close to you could cause disconcerting upsets within your relationships today. Both
Yeah.
bold of them to assume I have relationships.
Oh. Well, you see, like, and what astrological sign is that for?
Gemini.
Gemini. Okay, so but that can apply to anybody,
Yeah, yeah,
right?
exactly, exactly. Yes.
Right? And so that's the idea. Like these are Barnum statements. You read them, they're vague, they're general, but you kind of zero in and you go, "Oh, that's me." The same way the carnival guy might be like, "You look like a smart young man," and you go, "Oh, of course, yes, I am. Thank you." Um, So that's the Barnum effect, right? Yeah, happiness is in your future. Open the fortune cookie. Happiness is in your future. Me? Happiness? Yay. Well, that's so vague, right? So the Barnum effect is when we kind of succumb to these Barnum statements and we think that they refer to us specifically. That's one effect. There are other effects. I was going to say the psychophysicists discovered all kinds of effects, like um, in terms of the relationship between luminosity and perceived brightness, or sound pressure and perceived loudness, right? These are all effects. Um, Psychology doesn't really, at least not yet, it doesn't really discover laws. Not in the same way that a physicist, a chemist, or a biologist could discover a law. And the reason for that is that humans are really, 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 really complicated. But psychologists generally understand what they do as describing effects. But say these effects are like law-like enough, they're causal nomological enough, then what we would want to do is try and formulate our psychological theories that explain things like this, the same way that psychologists do when they identify effects. And this is called psychofunctionalism. And whatever one we choose, we better make sure it's correct. And Kim spends a lot of time kind of reviewing the strengths and weaknesses of each approach. Um, Folk psychology is not very scientific, but it is enormously successful. Scientific psychology is, well, it's scientific, but it's far from complete. Um, so really, which do we go with? I don't know. Um, we're not going to worry too much about this. The point is that we better pick the right one, because if our underlying theory is false, then anything that we try to generalize, as we did earlier with the Ramsey-Lewis method and our toy theory, everything we try to generalize from our false theory will also be false. Now, I think we've already discussed the strengths and a few strengths and weaknesses, or at least the ins and outs of scientific psychology and common sense psychology. I think what we ought to do now is take a break. Let's see. I have 3:50 on my microwave clock. So how about we come back at 5 minutes after 4, and then we'll finish off the rest of the slides. Sound good to all of you? Awesome. Well, I'll see you all in 15 minutes. All right, everybody. I'm back. Let us continue. Now we're going to look at um, some of the issues with going with either either of these, common sense versus scientific. Let's say that we were to go with scientific psychology. Um, well, we'd have to assume that our psychological theories posit internal states. Those are our mental states. And these systematize the correlations between our sensory inputs and our behavioral outputs. So again, think of the sense think act cycle or the classical sandwich. It's these mental states which are our causal intermediaries that make sense of all of the inputs and outputs. Um, let's say that we have our subject who we'll call S, and they behave in such and such a way. And we have two psychological theories, T1 and T2. Each do a great job of explaining S's behavior, but T1 and T2 each posit completely different inner states and different, as a consequence of that, completely different causal chains from inputs to outputs. And basically, what we're saying here is that both T1 and T2 explain S's behavior equally well. If we wanted to Ramsify one of them, that is to existentially generalize one of the theories, then it matters which one we pick. And how do we know which one is correct if they're both behaviorally adequate descriptions? That's one issue with going with scientific psychology. I don't seem to have um, an issue. I don't seem to have said anything about the weaknesses of common sense psychology on my slides. Um, I guess we're skipping those. Um, but is there a way that we can address this? Right? Is there a way that we can work out which theory is correct, T1 or T2? They both do equally well at explaining how we go from inputs through computation to outputs, from sense to think to act, but they both posit completely different causal chains between thinking and acting. Okay, so which is the correct one? How do we know? Yeah, yeah. Well, and that's the thing, right? Like the thing about common sense psychology is it's not scientific psychology. I think it's probably pretty safe to say that it's indispensable in our day-to-day lives, but it's not scientific psychology, right? Um, so, um, think back to Turing machine functionalism. According to Kim, on Turing machine functionalism, there are internal states of S that realize the internal states of the Turing machine in question. That is, there are in S real internal physical states that are causally related to each other and to sensory inputs and behavioral outputs as specified by the machine table of the Turing machine. So maybe my different brain states are a realization of a particular Turing machine table, and between T1 and T2, one of those um, Turing machine descriptions is going to actually map on to the physical states of my brain and my mental states, the causal pathways between the inputs and the outputs. It is the requirement to continue a physical realization that answers the question of the psychological reality of Turing machines purporting to specify the psychologies of a subject. Right, Timothy. Yeah, I knew who you meant. So which theory is correct, T1 or T2? The one that's correct will be the one that picks out the real internal states of S. So the theory that describes how S's internal states are actually physically realized. So, we get something like this principle. The states that the Ramsified psychological theory TR affirms to exist are physical neural states. That is, the variables M1, M2, etc. of TR, and in the definitions of specific mental states, that we looked at earlier, range over the physical neural states of the subject of psychological theory T. So now we can know which which one out of two equally good options, which one is the correct one. It's going to be the one that picks out the real internal states of S. as they correspond to Turing machine descriptions of S. And this is exactly what scientific psychologists and cognitive scientists do on a day-to-day basis, right? We could have two hypotheses that posit two different um, information processing systems. And what we try to do is see which one is actually implemented in the brain. You ever take a cognitive psychology course and look at information processing models of certain aspects of our cognition? Maybe somebody's here. There are only 14 of you here now. Oh, geez. Any one of you ever take a psychology course? Okay, good. Many. Great. So what's a sort of boxological diagram of something that you might get in a cognitive psychology course? Think working memory. Adrian has, but it's a while ago. That's fine. Is the working memory thing ringing any bells? Do you guys remember, oh, dementia testing? Okay, so that's part of the Montreal cognitive exam. That's the one that Trump keeps bragging about acing. When he says I aced my cognitive test, he's talking about the Montreal, which is what we give people for dementia to make sure they don't have dementia. Um, no, what I mean is something like, does anyone remember Badley's model of working memory? Let's find it. There it is. Here's a classic image from what looks like a textbook. Oh, come on, not Wikipedia. I just want the picture. Here we go. This is how Charles Badley modeled working memory. Said we have a system that works as a visual spatial sketchpad. We have a phonological loop. So this is for visual working memory. This is for auditory working memory. And we have a central executive. And information can go back and forth. This is an early model. Note here, it doesn't have an episodic buffer. Let's see if we can find one with an episodic buffer. Oh, here's a good one. So in later models, he adds this episodic buffer here, which is hard to see. But you get the idea. These are little cognitive systems: long-term memory, executive control, episodic buffer, phonological loop, visual spatial sketchpad. This is like for remembering, retaining visual information in working memory. This is for retaining auditory information in working memory. We can see that they can all, information can flow between the central executive, from the central executive to the episodic buffer and back, or from one of the visual or auditory components to and from long-term memory or the episodic buffer, right? I can recall something from long-term memory and keep it in working memory, right? This is an example of something that we call like a boxological diagram. Um, what we actually would try to do as scientific psychologists or as cognitive scientists, be a cognitive scientist as such, like I am, or a cognitive neuroscientist or a cognitive psychologist, as we try and come up with these information processing models that actually capture what's really going on in terms of physical realization. So if Badley's model is correct, there's a part of the brain that actually realizes the central executive. There's a part of the brain that actually realizes the episodic buffer. There are parts of the brain that actually realize the phonological loop and the visual spatial sketchpad. So if we have two models, one Badley's and one's something else, Goodley's, let's say, and we want to choose between Badley's model and Goodley's model, we need to pick the one that actually describes what's actually going on, what actually captures the inner states which maybe we look at physical realization if we're cognitive neurologists or cognitive neuroscientists. Maybe we look at the mental states if we're cognitive psychologists. Maybe we do a little bit of both if we're cognitive scientists. Um, but that's the point, right? Again, as Kim says, the states that the ramified psychological theory has to affirm are physical neural states. So um, the the mental states and their realizers. So if we have two models that explain working memory equally well, Badley's model and Goodley's model, we need to pick the one that actually captures what's going on the inside, not just what captures the behavior and explains the behavior, because they both do that. And so we'll end up going with Badley's model over Goodley's model. Make sense? Um, I'm not sure what you mean, Grant. Instant interaction? What do you mean by instant interaction? Um, well, I'm not sure if this is an answer to your question. Uh, but there is a limit to the channel capacity of our working memory. And it's about uh what is it? It's about 7 plus or minus 2, about 7 items. This is due to the work of George Miller. You can look up a very famous paper um, called the magical number 7 plus or minus 2, and it explains that owing to the channel capacity of our sensory systems, we can only retain about 7 items in visual or auditory working memory at the same time. And maybe if we're splitting that, we can remember even less. uh, like we can remember 7 in total. Like, has anyone ever done the digit span task? It's the task where you're read a series of digits and then you have to repeat them back. Yeah. It's part of like cognitive testing, not like the type that Trump does, but like if you're going undergoing a psychoeducational assessment and they give you like the Wechsler intelligence scale to see if like you might have a learning difference or like ADHD or something. They're assessing you for this, and they'll give you something to test your working memory, and they give you the digit span task. So the administrator will say like, okay, 5, 8, 11, 1, 3. And you have to repeat them back in order, or maybe repeat them back in reverse order. Most people tend to kind of be able to do this up to about 7 numbers, and then after that it gets harder, owing to the channel capacity of our working memory. Um, so Grant, I don't know if that answers your question. Um, so I want to turn to something interesting. Objections and difficulties with functionalism. And we're going to start off with a little mental exercise. I want everybody to look at this picture of the dress. And I want you to tell me in the chat what color the dress is. Go. Black and blue, gold and white, black and blue, gold and white. Yeah, interesting, huh? For me, it's gold and white. I've never seen it as black and blue, although the actual dress is black and blue. So if you're seeing it as gold and white, know that the real dress is actually black and blue. If you looked at it in real life, it would look black and blue. Do you know about this? This went viral. Wow, 2015. I'm getting old. This went viral in 2015. Basically, there was a woman who was getting married, and her mom was going to pick up the bridesmaids' dresses, and they had been ordered in black and white. And so her mom picks up the dress and says, "Oh, the dress looks great. It's black and blue. Here's a picture." And the woman to be wed said, "Wait a minute, they got this all screwed up. It's white and gold." And they go back and forth, via text, like, "No, no, it's black and blue. No, it's white and gold. What are you talking about?" So she posted it to Twitter, and apparently it divided the Twitterverse, what was Twitter at the time. Um, about half of the people who saw the image thought it was white and gold, and half thought it was black and blue. And it's come to be known as the dress, right? That's the dress itself and the social media phenomenon that it kicked off. Grant's seen it as both. Oh, and you can switch. Yeah, some people can switch, like how you switch with a Necker cube. You can switch the kind of have like a gestalt switch. I can't seem to do that. I've tried looking at it under different lighting conditions, and I always see it as white and gold. Maybe if I squint, or I don't know. It looks white and gold to me. But here's something interesting, right? Some people see it one way, some see it the other way, and some can see it as both. Um, and so there seems to be a difference in terms of our dress qualia, right? Which I think is really interesting. And this reminds me of one of the problems with functionalism, and that is that it doesn't seem to really do anything with qualia. So we have this thing called qualia inversion, or the inverted spectrum argument. And what this does is it says, look, functionalism doesn't deal with qualia because we could all have inverted spectra, or not all of us, but some of us could have inverted spectra. Um, so our qualia might be different, and we would never know it. We know in the case of the dress because some of us are saying it looks one way, and others are saying it looks another way. But if qualia inversion is true, we wouldn't know. Okay, so let's run through the inverted spectrum thought experiment. Let's say that I have a quote unquote typical spectrum that looks like this. So this is the visible spectrum. This is visible electromagnetic radiation. Down here, close to ultraviolet, where I have a wavelength of 400 nanometers, all the way up to the reds, which is like 700. Okay, so that's my spectrum. Now yours is flipped. So yours, you have red over here and violet over here. Now let's say we both look at a blue object. Okay? So let me get my little stylus out. So I look at a blue object and I see this color, which I call blue. You would see with your inverted spectrum this color, which you also call blue. So we could both be looking at the same object and I see it this way and you see it this way. And we'd have no idea of the difference because we both would refer to our inner experiences of these colors with the word blue. And that's the inverted spectrum. Black beetle. What's that? Oh, the beetle in the box. Yeah. Yeah. It's an example of that. Like, I say blue, you say blue. Um, my beetle is blue, but mine looks like this to me, and yours looks like this to yours. Yeah, it is like a beetle in the box sort of a thing. Um, get my drawings out of the way. Now, functionalism doesn't say anything about this. It's possible that we could have inverted spectra. We wouldn't know. Um, and this illustrates that functionalism doesn't deal with this. Like, not only would we not know if we all have inverted spectra, but on the sort of functionalism we've been looking at today and on Monday, this sort of thing is possible, but would be unaccounted for by machine functionalism or causal theoretical functionalism. Yeah, I mean, strictly speaking, it might not matter to you. But I think it should, because after all, consciousness is a big part of mentality. And we want our theory of the mental to be able to explain consciousness. It's even possible that you might not have any qualia. So remember when we talked about philosophical zombies? Philosophical zombies seem possible on functionalism. Or go back to Commander Data from Star Trek, who is an android. Um, Kim says Data is like an illustration of the absent qualia problem. I'm not quite sure if I'd go that far, but I would say that Commander Data seems to be phenomenally impoverished compared to his human crewmates. I mean, Data is aware of his environment. He represents his environment mentally. He's intelligent, but he doesn't seem to have um, the exact same kind of qualia that we have, right? He doesn't experience pain. He doesn't have emotions. So while I wouldn't say Data is a zombie, he seems to be impoverished in terms of his qualia, right? And qualia could be absent. If qualia were absent in our system, then that would basically be a philosophical zombie. Which, if I remember our discussion, many of you found that these kinds of zombies were not conceivable. So if they're possible on functionalism, that's a problem for functionalism. Maybe you'd reply, similar to how we dealt with some of those problems with the P zombies. You'd say, my mental state M is realized by a neural state, which we'll call P. We cannot differ with respect to qualia if we're in the same neural state. But again, how would we know? We can't know. The inverted spectrum problem is an epistemological problem, right? And this also doesn't address the problem if we're talking about creatures with very different nervous systems, like the octopus or Martians, right? We can say that, okay, your blue must look like my blue because we're realizing the same token of a type of neural state P. Okay, let's say we grant that. But how does that work for Martians or the octopus? Um, right? We could maybe say that qualia supervene on neurophysical states that realize them, but that might also be a problem. Why? Well, one reason why it might be a problem, which we'll get to later, is that with supervenience, I think comes a worry of epiphenomenalism, which we'll look at in our chapter on mental causation. Um, there's also the hard problem, which we'll look at as we get toward the last couple of classes in this course, where we talk about consciousness. We'll talk about Daniel Dennett. First, we'll talk about Thomas Nagel, what it's like to be a bat. Then we'll talk about Dennett, Quine, and Qualia. Um, but why? The hard problem, coined by David Chalmers. Like, why, why are we conscious at all? How can we explain subjective consciousness with the objective tools of the cognitive sciences? And why are our qualia the way they are in the first place? Why does coffee smell and taste like coffee rather than some other way? Right? Coffee could taste like something else. Why does it taste the way it does? And you might say, oh, it's because, well, the coffee qualia supervene on certain firing patterns in your taste buds and through your nervous system into your brain, maybe your olfactory centers or something, right? Okay, why? Why do I have that quale instead of something else? Do you see the problem? It seems like we have no choice. Or, well, we have a couple of choices. We can say, on a first pass, it seems like we can say, I don't know. Uh, that's just the way it is. But that would be like doing what Descartes did with Princess Elizabeth. How does an unextended thinking substance interact with a an extended non-thinking substance? We need contact. We need movement. And you're saying, this immaterial thing can affect and be affected by a material thing. And that doesn't make sense. And Descartes replies by saying, I just kind of take it as a sort of primitive notion, right? Is that what we want to do here with qualia? I don't think so. But that's why the hard problem is a hard problem. Yeah. Yeah, that's the thing. Like, and that's what Kim says in this part of the chapter. Like, the thing that, these functional theories of pain leave out is that pain hurts. There's something it's like to be in pain, and there's something that it's like to itch. So when we get to that's what gets us to the cross-wired brain thought experiment. So suppose each of us has a pain box and an itch box in our brains. Kim says. He continues, we can think of the pain box as consisting of a bundle of neural fibers somewhere in the brain that gets activated when we experience pain, and similarly for the itch box. Now, suppose further that, quote, a mad neurosurgeon rewires your brain by crisscrossing both the input and the output channels of your pain and itch centers. That is, the signals from your pain receptors now go to your former itch box, and the signals from this box now trigger your motor system to emit winces and groans. Similarly, the signals from your itch receptors are now routed to your former pain box, which sends its signals to the motor system, causing scratching behavior. Yeah, it does sound terrible. Should we sketch this out? So let's draw some boxes. So pain box, itch box. Inputs are, let's see, tissue damage, TD. And we'll put SI for skin irritation. And our outputs are pain behavior and itch behavior. I'm sorry for my messy sketches. So, tissue damage goes into the pain box. Something happens. Output, pain behavior. Ouch! Winces and groans, etc. Similarly here, skin irritation into the itch box. Output, itching behavior, scratching. Pretty straightforward, right? But now I'm a mad scientist. Change my color to a mad color. Pink. So I'm rewiring the input and output of my pain and itch centers. So tissue damage now goes to the itch box and outputs pain behavior like this. Grant doesn't like it. So now when I get skin irritation, it goes to my pain box. Presumably I experience pain, but what do? I scratch. So I've crisscrossed everything. On a functionalist view, right here, we would instantiate the same pain itch psychology. But this is another version of the inverted spectrum objection that we just looked at. See, if I'm this mad neuroscientist and I've crisscrossed things, say I've crisscrossed things such that signals from my pain receptors right here now go to my itch box, and signals from the itch box now trigger winces and groans. Now, presumably, what this is meant to highlight is that I might still have um, is I might now have pain qualia, but itch behavior, and itch qualia with pain behavior, caused by the same things that normally cause itches and pains. Here, I've got an equivalent pain itch psychology as somebody without a cross-wired brain. but our qualia would be all messed up. And functionalism doesn't seem to account for this. Or at least it's a problem on functionalism. Well, no, no, it wouldn't. What we mean by itch, I mean, I guess there's maybe a worry that, like, okay, we've, like, think back to Wittgenstein, like, the meaning of our psychological terminology is grounded in behavior, verbal and nonverbal. Um, but there is something that it's like to be in pain. Um, there is something that it's like to be itchy. And here, we've cross-wired the behavior. We've switched everything around so that the qualia don't match up with the behavior, with the in or with the inputs for that matter. Um, so, Adrian, go ahead.
Um, if let's say, let's okay. How do we know that the pain box and the itchy box is not the same box?
We could look at a brain scan and see that pain is being realized in one area with my C fibers, and itch is being realized in another area with some other type of neuron, say.
Is that actually what happens?
Not exactly, but there are pain centers in the brain. Like, um, there's a sort of functional differentiation in our brains, and neural reuse is a thing, as we talked about last time. But we know that pain is associated with C fiber activation and A delta fiber activation. Itch is associated with some other type of neuron.
Because what if they're both pain, but we adapt to, oh, I recognize this type of pain. The solution is to itch.
Um, yeah, I guess, but like you're still having a different inner experience. Like your qualia would still be inverted.
Right. Okay.
And that's what functionalism is missing. Like you could say um like oh, the reason I feel like scratching is because it hurts. And you could modify your behavior to, I don't know, take an aspirin instead of scratching. Your qualia would still be all messed up, presumably. Although I don't know, when we get to Dennett, we might find that this is not a problem.
Oh, so somebody asked in the chat if I think that scratching is a learned behavior. Um, if if I'm itchy and I scratch and it goes away, I had a problem. I solved it. Right? If I'm in pain and I'm scratching is not fixing it.
Yeah,
I don't know. I guess I don't know how. Like I would obviously know what feels to be in pain and being itchy. No, it's being in pain and itch and having the instinctive urge to itch. Right?
yeah,
But obviously that wouldn't fix it.
yeah,
So I'd still be in pain. So I guess I'd stop itching it. So then I'd have to describe it a different way.
yeah. Well, I think, well, the question is about behavior, right? So I think scratching is something we learn owing to the affordances of our bodies and the environment, and also there's a certain sort of like monkey see, monkey do kind of thing, right? Um, uh, I might see somebody, like I have an itch I can't scratch, but I see somebody using one of those long like scratching sticks that you can get at the dollar store. I think, oh, that's brilliant. I'm going to do that. I'm going to get one of those scratching sticks for myself.
Rub the wall.
Um, right?
Rub the
But
wall.
like if I have a mosquito bite and I'm just like, I do kind of instinctively do this. You know, I remember going to um, camp when I was a kid and getting covered in mosquito bites, and just I no one had to like tell me how to scratch. I just kind of like, I guess I figured it out. I imagine other children do. Or yeah, like Baloo rubbing against a tree. Okay, yeah. So you know the bare necessities. He's got to scratch the itch. Mowgli sees him do it, and he does it too. Right? Yeah, same idea. Right? Um, but that's the behavior, right? Um, if the cross-wired brain thought experiment is right, there would be a sort of qualia inversion such that we'd have the same. pain itch psychologies insofar as sensory inputs and behavioral outputs, but the inner sensation, the qualia, would be mismatched between the two behaviors.
So if I like lost my foot in an accident or something,
Hmm.
right? Obviously it's painful. Scratching it, that would be then itchy, all right? Scratching it,
Um, well, wait. So, are your pain? Is
well, that's
this
what we swapped it. Yeah, yeah, back to the same
okay?
idea. We swapped the boxes,
Okay.
right? If I lose a foot, I get hurt. That would be then feel itchy. If I then scratch it, the pain will not go away.
Uh, yes. Well, no. I have to go back to my diagram, which I've erased. I wonder if there's a way to undo that. Yes. Okay. Let's go back to our little diagram. So, tissue damage. You've lost your leg, but because we've rewired everything, now your itch fibers fire. So you still have a pain behavior like, my leg, it's gone. But what it feels like is itchy. Make sense?
Okay, so I think back to what Grant said. I'm interpreting scratching as a learned behavior to solve that type of pain.
Well, so it's important to keep in mind there's behavior and then there's qualia. So
Right,
here, the behaviors don't change. See, look, if I have normal pain box and normal itch box, I get tissue damage, pain, pain behavior. So tissue damage, ouch, winces and groans. If I itch, I have skin irritation, itchiness, itching behavior like scratching the itch. But if I crosswire everything so that I, say, lose my leg, now those signals go to my itch box, so I experience itch, but then I wince and groan. So the
right.
behavior is identical, but the qualia have switched places. Maybe it would be easier to illustrate it like this. Um, if I've crosswired my brain, then now what's in here is itch, the qualia, and what's in here is pain qualia. Make sense?
Oh, okay.
Yeah. Okay. Let's clear that again. Go to the other slide. There we are. Or no, this is the slide we're on. Um, okay. What about when you have lice or something? I had lice as a kid, and obviously it's skin irritation, but at a certain point it feels painful. Uh, I mean, so this is an interesting example because there might be a continuum uh, somewhere where itch kind of becomes pain at some point. Like if you scratch so hard that you actually cause tissue damage, right? It's hard to understand what you're saying because I can't even imagine that qualia switching. Yeah, I mean it is a thought experiment, so I don't know. Can we do another example with two different qualia that we can look at? Uh, trying to think of one that won't be worse. What about like pains and tickles? So, okay. So let's go back again. So now instead of itch, I have tickle, which will just let's okay, so now it's a tickle box, like a tickle trunk, like Mr. Dress Up. So tickles into the tickle box to tickle behavior, which is like laughing. And then tissue damage into the pain box to pain behavior. Now I crosswire it so that if I get tickled, I experience pain, but I still laugh. Or if I have tissue damage, I experience a tickle rather than pain, but I still make winces and groans. Yeah. Okay, good, good. Another thing that I think it's not a criticism against Kim, but this is not really taking into account embodiment. But that's neither here nor there. We don't have to worry about that too much. Um, Maybe what you make of this depends on what you think of the importance of roles of the information processing stuff, like the functional roles versus the importance of the actual physical realizers. Yeah, comedy is now horror. Yeah. Um, okay, so most functionalists want to believe the following. Firstly, psychological cognitive properties are multiply realizable. So, our mental states, our beliefs and our desires, our sensations, our emotions, everything mental, they want to say are multiply realizable. So, there's more than one way to physically implement them. So, I instantiate pain when my C fibers fire. The octopus instantiates pain when its O fibers fire, etc. Right? So, these psychological cognitive properties are irreducible to physical properties. There is more to pain than just your C fibers firing or your O fibers if you're an octopus. It's the role they play in the system as a whole. So that gets us to three. This does not affect their status as legitimate scientific kinds. So mental states, like if psychology or if the cognitive sciences are truly autonomous sciences, then mental states are legit scientific kinds that we don't want to reduce to neural states or neural events. There's something over and above those things. And it follows that the cognitive sciences are an autonomous science, and they're not irreducible to these lower level sciences like biology and physics. You will not explain mentality by reducing psychology to biology, is what this says. Now, maybe this reducibility is due to our focus on low level realizers. The C fibers, the O fibers. By focusing on all these diverse low level realizers, we might lose sight of their unity as properties. That is mental properties. We could be missing the forest because we're too focused on the trees. Instead of focusing on the realizers, we should focus on the roles of the realizers. So that gets us to these two different ways of understanding functionalism: realizer functionalism and role functionalism. Let's look at what Kim says of each. Realizer functionalism, quote, my experiencing pain at time t is identical with my C fibers being activated at t, where C fiber activation is the pain realizer in me. The octopus is experiencing pain at t is identical with its X fibers being activated at t, where X fiber activation is the octopus's pain realizer, and so on. The property instantiated when I experience pain at t is not identical with the property instantiated by the octopus when it experiences pain at t. Octopus pain and human pain are different sorts of properties, and they're different by virtue of the fact that they have different physical realizers. Role functionalism, on the other hand, has it this way. Quote, my experiencing pain at time t is identical with my being at t in a state that plays a causal role R. That is the role of detecting bodily damage and triggering appropriate behavioral responses. The octopus is experiencing pain at t is identical with its being at t in a state um, that plays the same causal role R, namely detecting tissue damage and triggering the appropriate behavioral responses, and so on. So my pain at t and the octopus's pain at t share the same functional property, namely being in a state with causal role R. So here we've got the same property by virtue of their role. Here we've got different properties by virtue of their of each state of pain having a different physical realizer. So Kim continues, where the realizer functionalist sees differences and disunity among instances of pain. There's a typo there. The role functionalist sees similarity and unity represented by pain's functional role. So a role functionalist would say that these role properties are really what the cognitive sciences are ought to be interested in. That's what we're trying to discover, these role properties. And what we want to discover specifically are what laws or lawful regularities hold for these properties. And as we saw last time, we can do this by focusing too much on physical compositional details of how the roles are realized. So this is closer to the strong functionalism that I discussed earlier. That's not the terminology Kim uses, but we can think of it like a sort of strong functionalism. Whereas realizer functionalism might be like a weaker sort of functionalism, where we do actually need to pay attention to the realizers. The role properties, however, they have to be robustly causal properties and nomological properties. So they have to play a causal role and they have to be law-like, like in terms of the input-output relations. They have to be law-like. That's what nomological means. As these two role functionalists, Ross and Spurrett, say, the foundational assumptions of cognitive science, along with those of other special sciences, deeply depend on role functionalism. Such functionalism is crucially supposed to deliver a kind of causal understanding. Indeed, the very point of functionalism on role or realizer versions is to capture what is salient about what systems actually do, how they interact, without having to get bogged down in microscale physical details. Sounds like how functionalism ought to be. But I don't know. Some people might think that we need to pay some attention to the realizers. Um, what do you think? Perhaps you don't have a strong opinion, and that's fine. Are there any thoughts? This is really kind of like getting almost into like philosophy of science stuff at the end of the chapter, which I think is interesting. It's not strictly speaking philosophy of mind, but it's like philosophy of cog-sci, maybe. So I think it's interesting. I do think it's good to be aware of the difference between role functionalism and realizer functionalism. And I want to make sure that you understand the difference. So role functionalism sees unity because they're focused on the roles as the properties that we're interested in. Realizer functionalism says that, you know, an instance of human pain and octopus pain, these are different properties because of different physical realizers. That's the in and out of it. Well, if there are no other questions or concerns, that is actually all I have for today. So we're finishing earlier than usual. So are we sure there are no further questions before I go?
I have a question about the proposal.
Okay.
So I'm getting started right about now. Better late than never. Um, do you want it in a style that is asking permission to start, or do you want it? This is what I'm doing. I kind of like in the tone. I'm gonna do it. I'm gonna do it, assuming that you said yes.
Yes, yes, yes. Do the second thing. It's like you
Okay.
want it, it's supposed to be like almost like a confident elevator pitch, right?
Oh, okay.
Yeah, yeah. And
So,
and I'll like Jack and I will tell you like if you need to change anything, we'll let you know. But we're not going to be like, no, you can't write about this. We might be like, to make it work, you might need to make these changes. But as long as it's got to do with the subject matter that we're learning or something related, yeah, you're fine.
and my topic, like the topic I'm looking at, is more or less talking to inanimate objects
Okay?
or things that don't talk back. So, like talking to your dog, for example. Your dog doesn't understand what the hell you're talking about. It understands your body language,
Yeah.
but like me
Well,
saying,
dogs are animate.
well, yes, of course, I'm saying, but like me saying, like asking the dog, like, why is it raining today, man? Why did it rain today? Like, I want to take you for a
Yeah.
walk. That's not
Well,
gonna know what it means to.
yeah. Okay. So that's an interesting topic. You've just got to make it clear, like what it is you're trying to convince me of, or what research question you're trying to answer.
Okay.
Yeah,
All right. Thanks so much.
yeah, no problem. Uh, how many proofs of work for the proposal? Two early drafts plus the final. For the essay, three early drafts plus the final. Timothy, go ahead.
Uh, I could just be having trouble finding it, but for the reflection assignment, I remember there's like a template that we sort of
Yeah,
had
there's a
structured.
temp. It's a helpful materials module. There's a template
Oh,
for the
proposal as
proposal.
well. Perfect. Thank you. That's what I was looking for.
No problem.
Oh,
And Grant says, I think I completely disagree with functionalism. Fair enough. That's fair. Uh, okay. Poe sent me a direct message. Gotcha, Poe. Good job. Thank you. The word limit for the proposal, about 500 words. You don't have to go beyond that. I'd say aim between 400 and 500 words.
so I guess do we try to do something similar to the first assignment, I guess, like if that went well for us.
Well, no, not exactly. Like you've got to do it as a proposal. Like follow my template, follow the instructions for the template.
Or we can like expect the same sort of idea. Like you look at the template and don't
Yeah,
need it.
yeah, yeah. Like follow the instructions
You
because
just
I mean surprisingly like there were a lot of reading response, not a lot, but there were some reading responses where I can tell like you just didn't read the instructions or watch the video. I mean not you Timothy, but there were some students who were like, well, you didn't read the
those.
instructions. Like yeah, so
Luckily, half the people left already, so like not.
yeah.
So
Um so as long just make sure you follow like there's a reason I put so much
right.
focus on the instructions. Like I give you the template with instructions and I spend a lecture on it. There's a reason I do that. There's a reason I want you to do it this way. So do it that way and you'll be okay.
Perfect. Thank you.
No problem. Okay. I guess that's it. Um yeah, that's cool. I mean, yeah, you can think of it like that as an abstract. Grant. Yeah, that works. That's a good way to think about it. Not you don't have to, but yeah, you can be like, okay, yeah, like my plan of attack would maybe be something that could end up as the abstract for my paper. Yeah, that's a great way to think about it. Thank you, Storm. I'm glad you find it all helpful. Okay. Uh, well, let's wrap it up then. Someone wants to see me. Bothaina? I want to make sure I say your name right.
Yes, yes.
Okay. So let's wait. I'll just stop sharing and we'll stop recording and we can meet. Dog is awake. Dog is not as high as before. Yes. Okay. So well, how much so for the people, okay. Well, first of all, I'll see you all next time, all right? So bye for now everyone. I'll stop recording. Bye for now.